So here's a look at the difference quotient, f of x plus h minus f of x over h. And we're going to apply this difference quotient to this function 3x squared minus 10x plus 7. So what I'm going to do here is I'm going to break it down into pieces. Um, this piece and this piece first. So let's call it the red piece and the green piece. The red piece of the difference quotient, which I'm going to write right here, just asks us to evaluate f of x plus h given this function, 3x squared minus 10x plus h. So f of x plus h means you plug in x plus h for all the x's into f. So the thing that doesn't change with f is you have 3 times whatever this is, x squared, minus 10 times x, but I'm going to replace the x, remember, so I'm going to replace it right here, plus 7. So anywhere I saw those x's in the f, I'm going to replace with whatever is in here, which happens to be x plus h. Notice I kept the exponent right here, the 2 and the 2, and this is really x to the first here. I kept that exponent. So I'm going to plug in the x plus h everywhere I see an x. And then I'm going to multiply everything out. You have to be careful here. You have to follow all orders of operation. So the first is I'm going to square out the x plus h. X plus h squared is x plus h times x plus h. You can do this on the side, or you can do the shortcut square double square if you know it. Anyhow, on the side, it would be first foiling it, x squared plus outside x times h plus inside x times h again plus last h squared. So x squared plus 2xh plus h squared. And you're going to plug that in here. That's one way to do it. I'm going to do it the shortcut. It's really helpful to know that shortcut. A binomial squared, x plus h squared, you can just simplify it like this. Square double square. It's the first term squared plus 2 times each of these two terms. So 2 times x times h. And then plus the last squared. So plus h squared. That's square, double, square. You can see you get the same thing. So it doesn't matter how you do it. Then I have minus 10 times x plus h, and then plus 7. I didn't multiply out the 10 yet just because I could have, but right now I'm going to distribute this 3. That's the next order of operation, and distribute this negative 10. So I have 3x squared plus 6xh plus 3h squared, and now distribute the negative 10 minus 10x minus 10h plus 7. And I'm pretty much done with that. So that was the green portion. It's not too hard. There's a lot going on, but it's easy. Now I'm going to write down this green portion, this f of x. So f of x equals, this is the easy one. F of x equals whatever f of x is given as. You don't have to do anything with it. 3x squared minus 10x plus 7. The thing I'm going to do, though, is line up the like terms. So 3x squared minus 10x, we'll put it right under this 10x, plus 7. Now, when you do this difference quotient and you do it right, and it's a rational function or a polynomial function like this, you'll always get that lining up. Like you'll always get those terms to line up. And now we're going to subtract this because that's what it says to do. See that minus here? Do f of x plus h minus f of x. So this was f of x plus h. I'm going to subtract f of x. And then all those like terms will subtract out to 0. So 0 plus 6xh plus 3h squared, that's gone, minus 10h. So that always happens. What also always happens, and it's a good idea to take care of this now, is everything that's left down there will have an h. So by factoring, you could, and by the way, remember, this is f of x plus h minus f of x. By factoring out an h, from all three of these terms, you'll be left with 6x plus 3h to the first minus 10. So now you've done the entire top of this quotient. So I'm going to take it. Hopefully I can. Well, down here a bit so I can see it. I'm going to start filling it out. So remember, this row I was left with f of x plus h minus f of x equals this. So that's what I'm going to put up top. You can ignore this. The top is just this simple h times 6x plus 3h minus 10. And you can see the rest of the difference quotient, it's over h. Now this is going to happen every single time. You can see that since we have a factor of h down here and a factor of h up here, you just simply cancel them out, and your final difference, simplified difference quotient, is 6x plus 3h minus 10. I should comment here that as long as h doesn't equal 0, because that's what would make this undefined. But here's your difference quotient. That's all there is to it.